So I decided rather than going and talking about units, we'll talk about how we use significant figures in calculations. Now, when we talk about units, that's like the really big important thing, and we do calculations with units. That's one of those really big important things. Significant figures is important, but it's not as important. You can do all your calculations without significant figures, and you can arrive at answers that are technically correct, but you're not going to be expressing the precision correctly, so you're not communicating well, but you're still able to do the math. And so, if I were to wait, because there's a lot of work in these next days, if I were to wait, like what you spend your time on, I'd be spending more of it time on unit analysis and then worry about the significant figures in the calculations after you got the unit analysis down. So with that being said, let's talk a little bit about significant figures in calculations. Before we get started, we have to sort of just generally review, right, the orders of operations, right? So just if you remember, PEMDAS, I forget what that stands for. There's like a mnemonic, but you do parentheses first. So if you have anything in parentheses, you do the operation of the parentheses first. And then you do any multiplication and division, and then following that, you do addition and subtraction. So have to keep those things in mind as we do this, because not only are we going to be doing our calculations that way, we'll also be tracking our significant figures that way. So we'll start with simple operations first, and then we'll get into operations that require us to use PEMDAS in the calculation. So if you're multiplying numbers together, right, what you do, and these, I did the calculations, so you don't have to like think about what the calculations are. How do you deal with significant figures? So if you look at these two numbers here, the 6.738 and the 2.11, right? There's 4 significant figures here, and there's 3 here. So in other words, I know this to one part in about 200. Like if I were to move that decimal place over, that'd be 211, right? So it'd be 1 out of 200. So I know that to about 1 in 200. I know this one to about 1 in 6,000. So in other words, in terms of precision, I know the 6.738 better on a relative scale. So that means when I do the calculation, it can't be any better than this number, because I know the 2.11 with less precision, relative precision. So that means when I take this answer, I'm really only going to round it to that place there. So in doing multiplication and division, squares, and powers and roots, keep in mind that the significant figures that you're going to get always are the same in the answer, are always the same as in the least precise number. So in this case, it's the 2.11. So then if I were to round it at this point, I would get 14.2 like that. Okay. Now, same thing, 12.99 divided by 8.1, right? I know this one to 4 significant figures, and I'll use parentheses to indicate significant figures. I know this one to 2, so I should only know this one to 2 significant figures, so that one will become 1.6. And both of these cases, since this number is less than 5, we are rounding down. If it had been greater than 5, just same as the other math rules you've learned before, we'd be rounding it up. Okay, so the next thing we'll do is we'll be looking at addition and subtraction. In addition and subtraction, it doesn't actually matter how many significant figures are in the number directly. It doesn't really matter. What matters is the column when you're doing your addition and subtraction, that you know all the numbers. So for example, I know this one to the tenths and I know this one to the hundredths. Okay, so think about if you're lining those up to add them together. 9.1 or 12.09 and 12.09, so or, I don't know why I said or, but anyways, I'm going to add those together, and when I do the math, I get 21.19. Now, I know the 2 and the 1, because that's what I get from the 9 and the 12, right? And I know that this is a 1 and a 0, so this is 1. This 9 is actually an uncertain digit. It's actually more uncertain because I don't know what this digit is. It wasn't written, so it wasn't measured. It could have been a 4. It could have been potentially a point 9.06, for example, so 9.06. It could have been rounded up to get 9.1. Remember how I put um, the pen on the scale and it rounded it to a whole number, so you couldn't tell that it was only 0.55. It was just hidden in I think it was the 11 grams or something like that. So when you're doing addition and subtraction, one of the simple things to do is you line up to the decimal and then you draw a line like that. And wherever you know all the numbers, that's the last significant digit in your answer. Now, you don't actually have to line them all up like that. You can just look to see, oh, this is tenths, this is hundredths, so I'm going to round to the tenths place. I'm going to round that one to there. And so that's going to end up being 21.2, like that. Now this number, there's a whole set of them here, right? So notice this one, I know the 10,000ths, thousandths, tenths, and the ones place. Since I only know this number to the ones place, when I add all these things up, that'll be the last place where I know all the numbers in the answer, and so that's going to be there. And so this will end up rounding to 22 in terms of significant figures and calculations. Now, it becomes trickier when you have exponents. And when you have exponents, what you have to do is to get them to the same exponential notation. Typically, that's getting it to 10 to the 0. So this number will become 6330. That's the last significant figure in that number. And then the 1.2 times 10 to the 2, that's going to be 120, like this. Right? And so when I add those two numbers together, I'll end up having a 0. I get I'm subtracting, sorry. Subtracting, I'll get a 1, I'll get a 2, and I'll get a 6. I mean, I looked up here, cheated. But it's good to this place here, because that's the last significant figure in that number, and it's also the last significant figure in that number. So this number gets reported as 6,210. Now that's an ambiguous number if you record it that way, so what we typically do, again, is convert it over to scientific notation. So I would say 6.21, and I'm going 3 places to the left, like that, right? So that is times 10 to the third, because if we go to the left, it increases, right? And to the right, it decreases. Okay, so that's how you deal with simple calculations, like just one algebraic step where you don't have to combine orders of operation. And so now what I'd like to do is show you some examples of where you have to follow the orders of operation. And I'm going to read some of this to you. I know you can read yourself, but I'm going to read some of the important parts, right? You still follow PEMDAS and you get the right answer, and you don't round it anywhere during the problem. So you know how here I got an answer and I rounded, right? When you're doing something that involves multiple operations, you don't round until you get your final answer. Okay, so next, that's what that first statement says. Next, what you do is you work through the problem and you figure out what the significant figures are after each of the simple algebraic operations like multiplication, division, addition, and subtraction. And you don't round it, but you just keep track of how many significant figures would be in the answer. And then what you do is when you get to the last step, you use those significant figures to tell you what the final answer should be rounded to. Okay, so let's take a look at this first problem, and that'll clarify some of the stuff that goes on. You notice I have a division, right? I have a subtraction at the top, so I'm going to do this first. Essentially, these are in parentheses. And then I'm going to divide by the 19.55. So I do the subtraction, I get this answer. And when you're doing these calculations, please hit equals after that. Don't just hit divide by 19.55, because your calculator doesn't read this the same way you do. It's going to divide the 8.234 by 19.55 and then subtract if you don't hit equals after you hit this top part. So every time you get what should be in parentheses, hit equals and write that number down. Okay, so this becomes 8.146. Now, I know this number to the hundredth. I know this one to the thousandth. That means I only know this number to the hundredth. And for some reason, I underlined all the numbers instead of just the last one. The 19.55 I know to this place, right? I just brought that number over. So that's 4 significant figures. This number, even though I wrote 4, is only known to the 8.14. So it's only 3 significant figures. Okay, so you notice what I did. I did the whole calculation. I got this answer. That's what this number is over here. So I'm bringing this mouse in. I got that answer there. Then what I did is I evaluated the number of significant figures that are at each in the numerator and in the denominator. And my conclusion was I had 3 significant figures here. I have 4 significant figures here. The operation that happens next is division. So I keep the fewest number of sig figs, and then it'll go to 3 significant figures. It will go to that point there. So this becomes 0.41, and then you round like that, 7. And again, I didn't round anywhere except that this is where you round here, okay? Round after last calculation. But I track the significant figures at each step. It's not hard to do. It's tedious. A lot of people don't do it just because it makes them crazy. But if you get in the habit of doing it, the nice thing about doing calculations like this is like if you make a mistake here and let's say you have like a completely wrong answer, you can kind of tell just by looking here and looking here. So if you have those intermediate results written down, it's an easy way to check yourself. All right, here's another one. So I have 16.3 plus 85.6, and that quantity will be multiplied by 127 minus 1900. When I do the calculations, I plug all this into my calculator. I get this number, and then I multiply them together. I'm going to round those, right? At this point here, this answer is good to the hundreds place because this operation is addition, right? So that means I have that as the last significant figure. For this one, this is subtraction, so this is only good to the hundredths place. So for these two, I have to the hundredths place because that's the least well-known digit, right? So that means I have 4 significant figures here. I have 2 significant figures here. And when I do the math, I get this number. Now, you would have gotten this number whether or not you track significant figures. So that's what I was saying. You just go ahead and do the math, follow orders of operation. You get your answer. Then go back through, and you do all your significant figures at each step, taking into account now this last step is multiplication, so I'm only keeping it to the second significant figure. And now I got to convert that into scientific notation. It's going to be negative 1.8 times 10, and I'm going to have to count, right? 1, 2, 3, 4. Oops, sorry, I went the wrong way with the decimal, huh? Nice. 1, 2, 3, 4, 5, like that. So times 10 to the 5th, because I went to the left by 5 places, so I'm multiplying it by 10,000 there. Okay, so that's how you do significant figures, taking into account significant figures. If it's a simple calculation, you just look at the number of significant figures for multiplication and division, and you round your answer to that number of significant figures. If it's addition and subtraction, you're going to take the places, just like I did here. This is the tenths place and the hundredths place, and I'll round it to the tenths place. If it's something where you have to do PEMDAS, where you have to do orders of operation, right? Then you follow the orders of operation, you get your answer, and then what you do is you track the significant figures, taking into account what operation you're doing at each step. At the end, you use those last calculations to determine how many significant figures will be in your answer, and then you round it after the last equal sign on your calculator. Okay, so you write down the number and then round to accordingly to the right number of significant figures.